Okay, for 4.6, we're going to start off by taking this function and setting it equal to 0 and solving. So we've actually done this before. We've taken a function and set it equal to 0 and solved. Notice that we have now a quadratic equation because we have an x squared and an x and a constant term. And the way that we solve this, if we can, we do it by factoring. If we can't factor, then we can use the quadratic formula. But if we can factor, it usually goes much, much faster. We now have two factors multiplied by each other, set equal to 0, and each one of these factors is going to provide us with an answer. We get x equals -4 from the first factor and x equals 1 from the second factor. That is it. I guess I'm just going to put -4, 1 into these parentheses, and that looks good. Now they're going to change things up on us for the next problem. In this problem, they give us a function, same as before. This time they ask us to solve this inequality. When is this function less than or equal to 0? So to actually solve this, the first thing that we're going to do is we're going to set the function equal to 0 and see where this function equals 0 first. Again, we have ourselves a quadratic equation, and probably the best way to solve any quadratic equation, if you can, is to factor. So we need two numbers that multiply to -24 that add to 5. How about 8 and 3? How about a +8 and -3? It looks like the function factors in that way, so that's perfect. That gives us two zeros. One 0 is going to be -8. The other 0 is going to be x equals 3. Now we know stuff about this function. We know basically what the graph looks like. We know that this thing is going to cross the x-axis at -8, and this function is going to cross the x-axis at x equals +3. We also know that this is a quadratic. It looks like a parabola. In other words, it has n behavior that looks like that, and then we're just going to connect the dots here. That is the very basic graph of what this function looks like. Now the reason I graph this is because I think graphing a function is the easiest way to solve these inequalities. If this question is asking us when is this function less than or equal to 0, what that means is when is this function equal to the x-axis, or when is it below the x-axis? When is it down here? When is this function less than or equal to 0? That means when are the y values of this function less than or equal to 0? So to answer this question, what we say is we give the x values for which the y values are less than 0. In other words, we're going to give all of the x values between -8 and 3 as our answer. We're going to include -8 and 3 in our solution with brackets, basically because we have an equal sign up here in our inequality. Part of this inequality is when is the function equal to 0, and this function is equal to 0 at -8 and 3, so we're going to include that in our answer. So we're going to use option B here and type this answer in interval notation since we have an entire interval for our answer. And that is it, and we're going to move on maybe to this problem here. We are asked when is this function greater than or equal to 0 this time. Not less than, but greater than or equal to 0. And again, what we're going to do is we're going to start by finding where this function actually equals 0. And to find where this function equals 0, if we can, it would be best to factor. So I'm going to factor. It's x plus 3 and x minus 1. The faster you can do this, the better. What this tells us is that we're going to have a 0 at x equals -3, and we're going to have a 0 at x equals 1. And if we draw a very basic graph of this function, again, it looks like a parabola, and it passes through this 0 at -3 and this 0 at x equals 1. Okay, so in this example, we are asked, when is this function greater than or equal to 0? That question means when are the y values of this function greater than or equal to 0? Well, the y values of this function are equal to 0 here and here. And the y values are greater than 0 here and here. So to answer this question, we're going to write down all of the x values in pink here. More specifically, this interval here goes from -infinity to -3. And this piece in pink over here is going to go from 1 to infinity. Now, I used parentheses here, but I shouldn't have, because we used solid dots here because we had an equal sign in our inequality up here. We're actually going to use brackets again in our final answer. Again, we're using intervals, so we're going to use option B. And that's going to do it for problem 3. For problem 4, we're given another function. Let's try it out. We are asked, when is this function less than 0? Again, if we want to find where a function is less than 0, we're basically going to graph it, but that involves first finding where the function equals 0. And this is kind of a fun one. We're going to get to factor quite a bit. Both of these terms have an x cubed in them, so I'm going to factor an x cubed out. That's going to leave us with the x squared minus 25. Notice that that is a difference of squares. That's x plus 5 and x minus 5. So when we finish our factoring on this problem, we're left with this. Now we have 3 factors set equal to 0. First one is going to give us a 0 of x equals 0. The second one is going to give us a 0 of x equals negative 5. And the third one gives us a 0 of x equals positive 5. Now this graph of this function is going to be a little bit more complicated, and you can use your graphing calculator here. So go ahead and do that, or use Desmos or whatever graphing tool you like the best. But what we know so far is that we have this function. It's going to cross the x-axis at negative 5, at 0, and at 5. We also know that based on the leading term, that the end behavior of this function is going to look something like that picture. I know that because we have an odd degree and a positive leading coefficient. So this function is going to look something like this and something like this as far as end behavior is concerned. Lastly, and this is getting a little bit complicated, so you probably want to go to your graphing calculator at some point here. But I know that this x equals 0 has a multiplicity of 2 because the power on that x, on that factor, is 2. I know that the multiplicity on this 0 is 1, and the multiplicity on this 0 is also 1. Those are both odd multiplicities. So what I know is that at this 0 of positive 5, my multiplicity is odd, so my graph is going to pass right through the x-axis. And oh my gosh, I just noticed that I copied this thing wrong. This was an x cubed from the very beginning. So our multiplicities, all of our multiplicities, are odd. We have a multiplicity of 3, 1, and 1. Sorry about that confusion. All of our multiplicities are odd. So what that means is at every single 0, our graph is going to cross right through the x-axis. And we're going to get a graph that looks something like that. Maybe there's going to be an extra wiggle in there somewhere. Maybe it's higher on one side than the other side. I don't know for sure without graphing. But what I do know is this. We are asked to find where this function is less than 0. So I know that the y values of this function are less than 0 down here and down here. They're below the x-axis. Notice that there is no equal sign in our inequality. So I'm going to put a circle here and a circle here and a circle here. And now to answer this question, we're going to write down the 2 intervals, the x values, for which this function is now colored red. So that interval would be here, and there's another interval right here. Those are the x values that we want to write down. So the solution in this case, it's option A, is going to go from negative infinity all the way up to negative 5, and I'm going to use a parenthesis this time to denote the open circles because we didn't have an equal sign in our inequality. And our other interval is going to go from 0 to 5, and we're not going to include the 0 or the 5, so that answer is looking pretty good. Okay, I think that's going to do it for this first part of this homework. I hope that you're getting the idea that basically what we're doing is we're graphing all of these polynomials, which you know how to do using graphing calculators. And we're looking at the graph and we're picking out where is the graph either above the x-axis or below the x-axis based on the inequality that we're given. Okay, let's do a few more problems in the next part.